Okay, we're going to look at some really simple polyatomic ions and how we can think about them forming. And we're going to start with water as a place to start. Water is not a polyatomic ion. It's a neutrally charged covalent compound. And so if we were to figure out, and one of your homework problems that you're supposed to do, you're supposed to figure this out. The Lewis dot formula for water looks like this. Okay? But water's not, let me just say it this way, there's no such thing as pure water. It can't be. Alright? And that's because a very, 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 very small number of water molecules kind of break apart. Okay? Some hydrogen ions, or some hydrogen atoms, break away but leave behind their electron. Okay, so remember, when we figured out how to make this Lewis dot formula, we had hydrogens as an electron dot formula and oxygen as an electron dot formula, and we showed how the electrons are shared to form a bond. Well, that hydrogen had one dot, one electron with it when it came to this bond. But what's going to happen here is it's going to leave without its dot, without its electron. Okay? So we're going to, yes, bye-bye. It's going to go away. Now, if it leaves behind its electron, it was a neutral atom with one electron and one proton. If it leaves behind its electron, what do we have over here? A positively charged hydrogen ion. And since a hydrogen, for the most part, is just a proton and an electron, if we leave the electron behind, this is a proton. Okay? So it's called deprotonization. All right? Now, so this is now this is not really an atom anymore. Remember, if it's a charged particle, it's an ion. So this is a hydrogen ion. You could just simply call it a proton. And since we were talking about monoatomic and all that stuff earlier, we can call this a monoatomic cation because it's positive. Okay? All right, so what's left when I take that hydrogen and it goes off on its own? Deprotonization. If you want to know, you know it right now, it's something we talk about a lot when we get to acids, but the process is called deprotonization. You can also use the word called ionization, whatever. But anyway, so if that happens, what's left over? What's left behind when the hydrogen leaves? Well, all the electrons are there, aren't they? Okay. There you go. It's not a negatively charged oxygen. It's a negatively charged thing. It's not water anymore, but it is a polyatomic ion. More than one atom. Atoms covalently bonded together with a charge. Huh? Yes, it's hydrogen oxide. But we don't call it hydrogen oxide. We call it hydroxide. That's the name of this ion. Hydroxide. You know that name.
Is that like hydroxycut?
Like hydroxycut, yes.
What does hydroxide make you white?
No. What? It's now a polyatomic ion, and not only is it a polyatomic ion, it's a polyatomic anion. Polyatomic because more than one atom covalently bonded together, and because it's negative, ion because it's charged. Okay? Huh? Alright. Now this hydrogen ion is kind of in the water. But it doesn't just kind of stay in the water, it does stuff. If I come up against another water molecule, remember the hydrogen ion wants to have how many electrons? 2, because it wants to be like helium, right? So this hydrogen ion could share, those two electrons right there. Those are lone pair. The extra electrons left kind of sitting around there, right? So we could plug that on right there, couldn't we? And now that hydrogen would have the two electrons at once, but when it came over here, it had a positive charge. The water was neutral. What's going to happen to this? What's this going to be? It's also going to be positive, yeah. So this is another kind of polyatomic ion. Okay, it's a polyatomic, not anion, because it's positive. Cation. I got to put the positive charge on here. And this has a special name too. Hydronium. Hydronium. Okay?
Why do you have to put it in correct? I mean in brass.
It's H2O2. Okay, now let's stay on this. I got one more polyatomic ion to talk about before we leave today. Okay? And it's going to be formed because I got protons. All right? So let's look at ammonia here. Again, remember we said we're going to look at ammonia again? That formula is NH3. And in that same homework assignment where you figured out this, you should have figured out that ammonia has a Lewis dot formula that looks like this. Okay? So this is a gas. Pure ammonia is a gas. But if I dissolve it in water, there's going to be some of these hydrogen ions sitting around. And what are they going to want to do if they get near this ammonia? What? Yeah. Why? An open spot. What is it the hydrogen wants? Like helium. It means we want two electrons. And looky here. Ammonia is, I say that looky here because we're in the south here, okay? Looky here. Alright? This hydrogen ion wants two electrons, and ammonia's got a couple of them to share. Okay? I grew up in the south. I can say stuff like that. Now, the ammonia was neutrally charged, no extra electrons or protons. But now we put a hydrogen ion there. What do we need to don't forget to do? What do we not want to forget to do? Positive. Okay, positive ion. So it's a polyatomic cation. Okay. And this has a special name. Let's see, I'm sorry. Wrong thing. Okay, ammonium. So ammonia is NH3. Ammonium is NH4 plus. Hydronium is H3O plus. And hydroxide is OH negative. Okay? Got it? Now I'm super simplifying some of this because some of this is really more complex than I make it, but we're trying to... For high school.